Hello and welcome to another video. So far we have been covering the binary search 3 problems in this series. I wanted to make some change, and now we'll be looking specifically through a course on Educative where the name of the course is Grokking the Coding Interview. And what I like about this course is basically the classification. So instead of going through each algorithm, they go ahead and identify the patterns which arise more or less in programming problems. And one of the patterns which arise in these problems is the merge intervals. And in this video, we'll have a brief overview of the merge intervals. We'll address a problem, and hopefully we will continue to address these problems in the subsequent videos as well. I'll be going ahead and solving all the other possible patterns in this series as well, so stay tuned if it is something which interests you. So basically the idea is, if you have two intervals and you want to identify relationships between those intervals, there are essentially 6 relationships which exist. One can be that both intervals do not overlap. Another relationship can be A and B overlap and B ends after A, which we can see here. They have really useful and clear graphics, so it's also easier to understand how things are working. We have where A completely overlaps with B, so B is contained inside of the A. We have A and B overlap, A ends after B. We have B completely overlaps A, and A and B do not overlap. So case 1 and case 6 are exactly the same, just the order has been switched. So let's look at the first problem and what it requires from us. So essentially the idea is, given a list of intervals, merge all the overlapping intervals to produce a list that has only mutually exclusive intervals. And they've gone ahead to provide a few examples. So for example, if we have a list of intervals like 1 and 4, 2, 5, 7, and 9, we see that these intervals overlap. So essentially, we could go ahead and merge these intervals. We take the extreme of the second interval and the lower extreme of the first interval, and it will be combined or fused into one as 1 and 5, and we retain 7 and 9 as it is. Here we have a graphical visualization of how it's accomplished. So you could say spatially represent all the input intervals on x-axis, and wherever the intervals overlap, you go ahead and merge the extremes. If one interval is contained in the other one, you just take the extremes of the larger interval. So for example, if we had 2, 3 here, you would just go ahead and take 1, 4 as the overarching interval there. We have another example where we go ahead and combine the interval 5, 9, and 6, 7. In this example, as 5, 9 contains 6 and 7 as well, and the resulting merged intervals would be 2, 4, and 5, 9. Again, we have an example here. All these intervals overlap, so we'll go ahead and simply merge all these intervals into the main extreme which we have here, which will be 1, 6. So let's try to go ahead and see how we can go about solving this problem. Again, I have not attempted this problem, so it's the first time I'm also implementing a solution, so please expect a lot of mistakes, but hopefully in the process we can go ahead and learn something out of it. So given that you do have this requirement of representing say all the intervals in an increasing order, the first thing we would essentially want to do is we want to go ahead and sort all the intervals. And to highlight one thing is we do have an interval class here, and each instance of the interval contains a start and an end. And we also have a print interval function inside, method inside, which we can use to print the interval itself. And we can see that we provide a list of intervals into the merge function here. So just to keep that in mind, what will be the form of our input? So as the first step, what I would like to do is I would go ahead and sort intervals, but I assume we need to provide a key here. So we want to do this sorting on the start function. We want to use the lambda here. So I believe this should work, where we are sorting, and we are sorting based on the first element, or sorting based on the start. Okay, just as a sanity check, let's print out the intervals, and then we'll go on to the solution further. Okay, so this, okay, I'll quickly look it up. Lambda for sorting in Python. So you sort a key. Lambda. Okay, so this is the problem actually. Okay. They do not have console output. Okay, this is interesting. Okay, so we believe that the intervals have been sorted, or yeah, we can just iterate through the intervals and print them here actually. So essentially, for interval, for I, intervals I dot print interval, and we'll see if the order is what we would expect. Okay, so yeah, we see that the sorting has happened based on the first element, which is what we expected as well. So at this point we are good to go. Our array is sorted, and let's see how we can go about approaching this problem. So so essentially so the way I'm thinking of approaching it at this point is we keep a track of start and end. So in this case, it will basically be our interval start. So the first element in the list of intervals. And at this point, what we want to do is we want to iterate through all the elements of the intervals and see essentially which intervals will merge. So for I in and because we've already used the first element, we would not go there. So we get the new interval. So we essentially get the compare interval. So let's do comp start equals to interval I start, comp end equals to intervals I end. And so basically looking at the conditions which we looked at above, and the fact that we have already sorted. So the first thing which we have to ensure, we are sure of, is start of the first element will be less than the start of the, say, subsequent element. What we have to make sure here, and the merging condition would essentially be if this start of the second element is less than the end of the first element, and this would invoke merging. And essentially, once we identify that there is some overlap, we can retain the maximum of the end of both the elements as the other extreme. So we know that the first extreme is basically the start of the first element, and now we want to check if there is an overlap. If there is an overlap, we go ahead and keep the other extreme as the end of that interval. So basically, let's compare the end of the first element with the start of the second element. If end is more than equals to comp start, this is basically our overlap condition. In this case, again, what we want to do, our start remains exactly the same, and we'll update we'll update our end. So end will basically be the max of end and comp, and whichever ends later. And if this isn't the case, we simply update our start with say comp start this intervals.start, and end will be simply intervals.end. I'm just trying to keep the things clean, and what we essentially want to do at this point is we want to use the merge intervals and append intervals, let me see, interval start and end, and we want to return the merge at the end. So this is the condition when we do not have an overlap. Overlap condition. Okay, let's just go through it again for a sanity check and finding holes in our implementation. So we sorted the intervals based on the start. So we have all the intervals in spatially organized order. We go ahead and fetch the start and end of the first element. We start our comparison, and basically the comparison is like here, we know that the first element will be always less than the second interval. The only way to find the overlap is the start of the second interval is less than the first interval. If this is the case, we will go ahead and choose the other extreme, the first extreme being the start of the first interval, and this would lead us to finding the merge with the start and the end, which would be this. We already have the start here, we define the end, which will be either so if this interval is actually overarching and the second interval, say, is contained inside, it would simply mean that the end which we had to start off with will be actually the end we want to look at. If this interval extends the first interval, we just take the maximum of the end here. And else, if there is no overlap, we simply go ahead and update the start at the end. And just so that we have everything in the merged, we go ahead and merge this start and the end. So either way, if there is an overlap or there isn't an overlap, we have to go ahead and put this into the merge itself. Okay, I would also print the merged here. Hold on, so we can see what is inside merged. So I believe essentially what we want to do is we want to append an interval before we switch the start and the end. So intervals start end. Let's see if we have the interval right. It should be interval, and we also have to do the merge, the final interval after the loop for loop ends, essentially. So these were the two instances where we want to merge, and I was missing them. This would complete our solution. Let's have a look if the outputs are in line with what we would expect. They indeed are. And of course, as we can see, as we are iterating through all the intervals only once, let's quickly jump in and see what the complexity of this problem is. We are iterating the intervals only once, which will take O n in the beginning. Since we sort the intervals, our algorithm will be O n log n, because the sorting in itself is n log n, and hence our algorithm or the time complexity will be n log n, and the space complexity will be O of n, as we need to return a list containing all the merged intervals. We will also need O of n space for sorting. Okay, so like again, we have a solution here. A similar problem would be given a set of intervals, find out if any two intervals overlap. Okay, so like again, I hope you enjoyed the process of going through solving a problem, please let me know in case there are questions. In the following videos, we'll try to go ahead and address other questions as well. And I'm trying to switch from Algo Expert to this set of problems, as the patterns I've identified, they provide are much more intuitive and easier to solve problems later on. So please let me know if this is what you like as well, and I'll continue to provide more insights here. Okay, until the next video, enjoy your day.